Hi, this is my lecture about forecasting techniques. During the previous video, we covered a little recap about making partitions in the data, which is a topic that is very important for you to know. Now we are going to cover an introductory topic to forecasting techniques. It's very broad, and after this lecture, we are going to focus in more applied economics and more applied forecasting. So let's start. Let's go to my full desktop. Okay, so please allow me these metaphors. I think I am going to use a lot of them today. So the forecasting techniques are something like different styles in fighting, yes. So we have many of them in here, and everything or all these styles have their ideas behind. Yes, so they are very important in that. So what you are going to do is actually to get the ideas right behind the forecasting techniques that we are going to use in this module. So that is why I have here Bruce Lee. Yes, empty your mind, be formless, shapeless like water. If you put water into a cup, it becomes the cup. You put water into a bottle, it becomes a bottle. You put in a teapot, it becomes a teapot. Now water can flow or it can crash. So I think this is very important because that is exactly what we want to do with forecasting. We want to adjust to the trend the most we can in order to forecast what we want to forecast. So in trying to fit the data, I think these quotes actually are very close what we want to do. In general, we have to do two ways in order to achieve that. The first one is model based. It's called model based because we can actually use other parameters, yes, and those parameters are going to get coefficients, yes. And there is another method which is data driven, which is it uses the same series that we are using to forecast. So examples of this are naive forecasts, smoothing, and neural networks, which are in here. So we can use previous data in order to forecast the same data series. I want to say that neural networks also allows the include of other parameters, such as, for instance, if we are forecasting GDP, we could add their other variables such as I do not know any other fundamental in the economy, right? Um, this does not happen with naive forecasting and smoothing, and it does happen with these model-based restrictions. So with these ones you can run a lot of theoretical models. With this one is just mathematics, particularly in neural networks is probably computer power. Yes. So in order to choose what is best for you, I think the amount of data, the amount of knowledge, global and local patterns are very important. Together, whether you are using a model based, a theoretical model, yes, this one is very important. If you are trying to beat like the forecast of someone, probably this is a good model in order to try to find a superior forecast. So why so many methods? So we have extrapolation methods. In terms of extrapolation methods, we have, and this is one of the examples, we have the same data series here. So say that GDP is a function of the previous year GDP and the previous 2 years GDP, so 2 periods of time in my data set, yes, and it depends on many other if I want. So this is the use only of history of series itself. Yes, so I will not use any other variable different from GDP in this set. We have econometric models. Econometric models are nice in the sense that it allows for the inclusion of a leading indicator for y, yes, and also variable x's, yes, which are coincident indicators of y, yes. In this setting we can also use like extrapolation methods, so use of the history of series itself, as you can see. So I think we have a lot of uh, um, room here to include many types of variables in econometric models. We have external information, which are these parameters that are explaining the model, and they are not the same, and the use of other series in order to calculate econometric models, and the inclusion on basis of correlation. There is a very interesting example, another research for Leonard Lauda and still other companies is about the lipstick indicator. The fact that um, lipstick sales increase just before recessions. Why do you think we have this finding? Well, the answer is that um, before the recessions, as lipsticks are like the cosmetic that is more cheap to buy, therefore women buy a lot of lipsticks before the recession. So they stop buying more expensive stuff, and lipsticks increases just before recessions. So this is a very interesting point. So we have here an example of an econometric model, yes, tourist demand. So we have here the log capita visits to Spain, yes, in time, right? And the idea is that we want to forecast the annual numbers of holidays in Spain taken by UK residents. So we have this data series, and this data is taken from this research from someone with data from 66 to 94, yes, and is interesting in which it allows us to use an econometric setting here, yes. So this LP means log, yes. So if you've seen a lot of logs in here, yes. So for instance, the first variable PVSP, yes, VSP is the number of holidays in Spain taken by UK residents, this figure here. And we have then an intercept, which is C1, and an error term as well. We have these two variables that are capturing errors, yes. And this in this setting, in this setting, you can see how we have here a lag variable, yes, because it's the same dependent variable but in the previous time series, yes, t minus 1. This is the coefficient theta, yes, right? And we have here as well another variable, which is PDI, UK real personal disposable income, and also CSP, which is this CRISP, yes, this variable, the consumer price index in Spain, and this one as well, divided by all these variables here, so the implicit consumer. So as you can see, we can model different type of examples, yes, for tourist demand. Allow me another metaphor here. The matrix is real, yes, it exists inside the masses as form of social, cultural, political, and educational indoctrination and collective psychosis. So imagine that we want to use this sentence of the matrix in order to forecast a collective psychosis. So you can find a variable as well for instance, social um, inculturation or political and educational indoctrination. Yes, so we can use variables that are in line of indoctrination in these fields in order to try to arrive to the question of whether we have a collective psychosis. Well, I think this slide is simply to say that we have manual versus automated forecasts. Um, Usually we have a manual forecasting when there is just one forecast and in-house expertise, a small number of series, and is typically model-based methods. Yes, so we use certain theory in order to try to um, model certain specification using a model-based method. Yes, um, and we have automated. Yes, usually automated are more driven data methods because they are very cheap in terms of computational power. Yes, so you will see, for instance, robots using a lot of these techniques in order to forecast very quickly, and not just proper physical robots, but virtual robots trying to beat things on internet, on the markets, and anything that is digital. A very important example of that, of automated uh, forecasting, is, for instance, the time that Garry Kasparov, the former world chess champion and author of Deep Thinking, the book, opened the OECD conference, Artificial Intelligence and Intelligent Machines. He had a contest with a computer called, a big computer called Blue Deep. Yes, and I think actually the computer beat him. I think Garry Kasparov is one of the most well-known champions or masters in the world. So he's a world champion for many years. Another example, and probably the most important issue that I want to remember out of this video, is the topic of ensembles. Ensembles is the fact that you can combine different forecasts in order to win. Yes, in order to buy the drinks. So we have, for instance, an example here, which is the Netflix prize. I believe that the winners earn like $1 million or something like that. I regret not to have participated from this, because actually the winners use like methods that we are using in this module. Yes, and they just use an ensemble. So they have like 3 forecasts, they sum them up with different weights, and that's it. Voila, they won the competition. So ensembles, what they are, they combine forecasts from different methods and combine forecasts from multiple series measuring the same phenomenon. For instance, the weather. Yes. So that's it. I think that is the most important thing from this session, the fact that you can use ensembles in order to get better forecasts. Multi-level models fit one methods to another methods forecast errors. Yeah, so we have as well multi-level methods in order to try to forecast the beta models. Yes. So what we do is to try to forecast something, and we provide a forecast of the errors. So as you remember, once we forecast, we have our forecast, the actual value, and the difference between both of them are the errors. Yes, so if we are allowed to like find a data set of these errors and forecast the errors and get something from these errors, I think we are using multi-level models, right? I have tried to do that in investing as well in the stock market. Here there is a very nice example. So everything that you have seen in the movies about face recognition is regrettably for many people very bad. Yes, because it's true. So we can also use this face recognition of forecasts by weighting or averaging the weights of and the measures in our faces. Yes, so computers measures the distance between eyes, the distance between mouth and nose, and nose and eyes, and the size of your head, and etc. Yes, and in doing that they are able to forecast what is like the look of a person from a certain country. Yes, so if we combine forecasts, we can weight them. Averaging, for instance, is a method. The weights are proportional to method performance, data reliability, and the weights can be obtained via regressions. Yes, we can have also dynamic weights and try to calculate what are the correct weights in order to combine our forecast. I think that method is actually very powerful, and there are many topics in terms of and researches in terms of combining forecasts in better ways. Particularly, I have here then the faces of very different women. So what the software has done is to forecast how is the look of a person from Germany, a woman from France, the woman from England, the woman for the Netherlands, the woman for Mexico. I think probably the Peruvian face is the closest to the Colombian one, so we are something in between these three here, probably four here. I would say that a Colombian person can look like any of these four pictures. I think in Colombia we are very mixed. Right, so what are the disadvantages of combined forecast? Well, increased costs, the need to analysts who are familiar with a number of methods. So if you do not have a person that is familiar, therefore it's going to be very difficult to carry on following that in any business. And the need to ensure that a predetermined rule for combining is agreed upon. So if it is not agreed upon, it's very difficult to like use that in a organizational environment. Yes, otherwise it's going to be very easy to manipulate forecasts. Yes, and obviously that causes a lot of problems in organizations. Why is not common to use combined forecasts? It is counterintuitive. Yes, so people think you only get an average forecast, and they believe that if they can pick a method, they will do better. Yes. Um, so the solution is too simple sometimes. Yes, and usually people like complex approaches. I think I used to have that problem a lot when I work in other universities because sometimes practitioners would like to get very complex approaches. So, for instance, vector auto ECM or vector autoregression, or they want to get the best or the latest econometric technique. Yes, and sometimes a simple naive forecast is very difficult to beat. This is the price. I think it's in dollars, $1 million for these people who found a beta forecast by using an ensemble. Um, the scientific truth about ensembles is that they are more robust forecasts because they are using not just one but many. That is exactly the case that we are using for the R rate of the pandemic, using different type of forecasts in order to forecast a single one, and they provide higher precision and less errors. So in doing that is like using like the karate styles of many other cultures, right? Or the fighting styles of many other cultures. So when you get an example, usually you get more consistently you are going to beat your opponents. I think that was something that Bruce Lee did very well. So ensembles produce the best improvement when the different forecasts are correlated, yes, either positively or negatively, and also when they are uncorrelated. So I think that is the most powerful tool of these ensembles. Okay, guys, I have this problem for you. Is about the ability to scale up renewable energy. Yes, especially wind power and speed. Yes, that is dependent on the ability in its short-term availability. Yes, so this author Sommer et al. 2010 described different methods for wind power forecasting. Yes, so we have here the methods, persistence method, the physical approach, the statistical approach, and the hybrid approach. So the problem is that for each of the four types of methods, we have to describe whether it is model-based, data-driven, or a combination, or for each of the four types of methods, describe whether it is based on extrapolation, causal, modeling, correlation modeling, or combination. And finally, describe the advantages and disadvantages of a hybrid approach. So that is what you are going to do now. I will make you can make a break here in your computers and try to solve this quick problem. Okay, guys, so that's it. Thank you for attending this video. Allow me this metaphor. Uh, it's better to find someone or to like forecast or predict what is in certain place, yes, uh, for instance in an airport, not just with one dog. If you have three dogs, it's going to be easier. Yes, so here allow me this new like metaphor. These three dogs are three forecasts. Obviously, they will consistently look and find for the things that are hidden, or for people if they are lost, or for any other problem at an airport. Okay, guys, I think that's all. I will see you in my next video on more applied economics.